Hello, welcome back. Thank you, Alan and Mike, for the roadmap sessions. There are so many features that have come out in the last 6 months and are coming in the next 6 months that I just don't know how we fit it all in. Right now, we've been talking about EKS Anywhere in multiple sessions, and I want to have Vipin and Vignesh come on and join me because we're going to demo it, and I can't wait to see the demo and then hear, so we can tell everyone about what is EKS Anywhere, how did we get here, and what is it used for. So first of all, Vipin, hello. Tell me what you do at AWS and with EKS Anywhere.
Thanks, Justin. Hey, everyone. Thank you for joining our session on Amazon EKS Anywhere. My name is Vipin Mohan. I'm a product manager on the EKS Anywhere team.
And Vignesh, how about you?
Hey, hey all. This is Vignesh Gautam. I've been working as a software engineer for EKS Distro and EKS Anywhere for almost a year now.
Yeah, so if anyone doesn't know, EKS Anywhere launched in August, actually September. It was early September. It was a blur of a month. But early September it launched. It's an open source project, and let's dive right into it. I know, Vipin, you're going to tell us a little about the project itself, and Vignesh is going to do our first live demo of the day. So let's get started.
That's exciting. Cool. Yes. So the objective for today's session is to demonstrate, on-prem Kubernetes cluster creation and operation with Amazon EKS Anywhere. Like Justin mentioned, we just GA'd Amazon EKS Anywhere last month. So it's been about a month since the product has been GA. So in our session today, we will this is the agenda that we're going to cover. So we will talk about what are the customer pain points for Kubernetes on premises, and what is EKS Anywhere and how are we trying to solve some of those pain points. We then jump into a demo. So Vignesh has some exciting stuff to show around cluster creation and also the GitOps capabilities later on in today's session. We'll also talk about how you can get support for your EKS Anywhere clusters. And towards the end, I'll talk about the components that you get, the bundled components, as well as the prerequisites that you need for running EKS Anywhere. And we'll have some pointers for resources and community towards the end. So with that, let's jump in. So a number of our customers told us that they have existing investments in hardware that they want to leverage. So they have regulatory or governance requirements sometimes that define where they can actually deploy their Kubernetes workloads. Sometimes customers are looking to reduce costs, or they have a desire to use open source software and leverage all of the aspects of that stack on premises. There are also customers who have a need to run compute and Kubernetes on infrastructure that is closer to their data center and their end customers. Think of latency-sensitive applications wherein it's important for a customer to be closer to their end users so that they can deliver the best-in-class experience. So those are some of the use cases that we attempt to address with EKS Anywhere. And with EKS Anywhere, you get consistent and reliable on-premises Kubernetes operational tooling that's consistent with Amazon EKS in the cloud. So EKS Anywhere builds on the strengths of Amazon EKS Distro and provides open source software that is up to date and patched. So you as a customer can get a reliable and secure Kubernetes environment on premises. Second thing is, you simplify on-premises Kubernetes management with Amazon EKS Anywhere. So we provide tooling for automating things like cluster management, cluster lifecycle management. And all of this is open source, and we will continue to maintain the project. So EKS Anywhere is built on the open source cluster API project, and it's not locking you into any proprietary technology. But we also include cluster lifecycle management tooling that allows customers to get a consistent operational experience with Kubernetes across different environments. We're also bundling some key components, things like a networking plugin, some operating system options, also a Flux controller for GitOps practices. And all of these help accelerate the readiness of your production clusters on premises. So right now, a lot of our customers have virtualized environments on premises, and they can use EKS Anywhere out of the box. But some of our customers have indicated that they actually also have bare metal environments. So our team is working on bringing support for EKS Anywhere for bare metal environments, in addition to the virtualized environments that we support. So we actually put together this chart to help you think about the different deployment options that we have across EKS on AWS. So Mike walked you through some of the roadmap items for EKS in the previous session. But the way to think about this slide is, towards the left, you have a customer managed option with Amazon EKS Distro. So it's fully open source. It's the Kubernetes bits that we use for running EKS on the cloud. And with EKS distro, the customer manages everything, all the way from hardware, control plane, data plane, and when the support is with the community. Contrast that with the right-hand side of the slide, and you have Amazon EKS, wherein the hardware is managed by AWS. It's a managed control plane that you get. The data plane and security are a shared responsibility model, which Mike touched upon as well. And support is with AWS. So Amazon EKS Anywhere falls somewhere in between, and in the sense that it runs in your on-prem data center. So the customer owns and manages the hardware. With EKS Anywhere, you install the control plane, but then the management is with the customer. Same thing with the data plane as well. Support, you can sign up with AWS. We'll talk about that, and you can get support for your clusters. And security is a shared responsibility model. And what I mean by that is AWS will provide you with the tooling. For example, the security patches, the CVE fixes, all of that we will provide. But the actual act of operationalizing those and installing those patches is up to the customer. So that's a high-level overview of what EKS Anywhere is and why we built it. And Vignesh will now walk you through the cluster spec that we use for EKS Anywhere, as well as the cluster creation, a demo.
All right. Hey all, once again.
Yeah,
am I muted?
No, you're good. I'm just saying you need to make the screen a bit bigger. Text.
Oh, okay. But now. So EKS Anywhere is actually built in a way that it's actually a plugin to the EKS kettle command, so that we can use the existing EKS kettle command that we all use for our EKS clusters. So the first command that a user would want to run is EKS kettle anywhere generate the cluster config. So over here, let me just increase the font size a bit. So over here, so I'm running the generate cluster config command with a name for the cluster, and then I'm specifying the provider to the vSphere. So today EKS Anywhere supports the provider to the vSphere. We have future providers in progress. So once we run this command, this basically generates a YAML file, which the user has to open up and edit. So let's take a look at an example YAML file, which I've pre-filled with some configuration, and we can talk over it. So the first section over here is the cluster definition, and this has all the cluster-wide configuration that we'll be using for the EKS-A cluster. So the first section over here is the networking section. So we've chosen our CNI to be Cilium over here. For now, EKS-A only supports CNI, the Cilium CNI. And then down below over here, we have configuration to provide in the CIDR blocks for both of our pods as well as services. Down below, after the networking section, we have the control plane configuration. So over here, we have the counts over here. It basically says how many nodes ends up being the control plane, the IP address for the control plane endpoints, and then we also have a reference to the machine group. So we'll just scroll down a little bit, take a peek at the machine group reference, just as an example. So over here, since the provider that we are using is a vSphere provider, the machine reference is actually a vSphere machine config. So you would see configuration which pertains to how a VM should be created for that particular node. So this basically has what the disk size should be, what's the folder structure that I have to create the VM in, like inside vSphere environment, what the memory should be, what the CPU count is, what the resource pool is. The OS family over here specifies what host OS I should be using for those nodes. Today, EKS-A supports both BottleRocket as well as Ubuntu OS families. So down below,
just a question from the chat too about Windows support. There was a quick question I thought we'd bring in. You just mentioned that we support Ubuntu and BottleRocket right now.
Yeah. So for now, Ubuntu and BottleRocket are the only supported OSs. We do not support Windows at the moment. Yeah, and then we have a provision over here to specify in an SSH key so that the user who's creating these nodes can, in the future SSH and do some operations over there. Going back to the section that we were above, so the next one after the control plane configuration is the data center reference. So similar to the control plane machine config, the data plane is going to have some configuration details, which is specific to the particular vSphere data center. Stuff like what's the network that I should be using for my cluster, what's the server endpoint for my vCenter, what's the data center's name, if there's any thumbprint that I should be using, or if the connection should be an insecure or a secure one over there. So after that, we can talk a little bit about the external HCD configuration over here. So EKS-A supports both stacked as well as unstacked external HCD configuration. Our recommended option is to choose the external HCD configuration so that the HCD cluster itself is independent of the control plane. So over here, you have configurations for those, like the minimum count over here. Once again, a reference to the vSphere machine config, which basically has the same, the template to be using, the OS family and whatnot over there. The next field is Kubernetes versions. Today, EKS-A supports both 120 and 121 for the Kubernetes versions. Similar to the control plane node configurations, you have the vertical plane node configuration. It counts over there. The vSphere machine config references over there. So the next two fields are actually optional ones that we could use. So EKS-A supports a proxy configuration. There might be some environments where the cluster doesn't have, or the environment doesn't have access to the public internet. It has to be routed through a proxy endpoint. So we can specify those details configurations over here, both HTTP and HTTPS proxy endpoints, as well as no proxy. You could see that we support, CIDR blocks, IP addresses, as well as domains over here. GitOps ref, we can scroll all the way down and take a look at the GitOps configuration. Today for GitOps, we only support GitHub at the moment. We can specify both a personal repository as well as an organizational repository over here. We give it the name of the repository and the owner for the repository. So this is basically a GitHub ID. The repository here, if it doesn't exist, the EKS-A would generate a repository for you, create one, and then put all the configuration for the cluster in checked in over there, so that you can use it at a later time. So once this configuration is all filled up, you would technically run the EKS-A create cluster, supplying in this file as an input. So just as an example, I've run this before so that I could.
Yeah. Let's make that font bigger. And just going through like the general workflow here, where a lot of people that run Kubernetes are used to, I create an application with a container, I create my YAML file to deploy that container, however it is, and then I have something running. In this case, we're doing that in EKS Anywhere at the cluster level. And this is pretty standard for how Cluster API is doing it, where we say, hey, we want to define this YAML describing our cluster. You went through all that, great, to show how many worker nodes, how many control plane nodes, where etcd is running, everything configuration we need for what OS. And then now we just say, okay, take that YAML and apply it, right? So like this is the same workflow, declarative workflow we get with Kubernetes for workloads. We do that at cluster level with EKS Anywhere.
Yeah,
cool.
That's right. So this is what an output would look like when you run the create cluster command. So I've I've run it with verbose logging over here just so we can see what's happening behind the scenes. So it's validating the GitHub the PAT token, the personal access token, which enables the workflow to create repositories or clone it and check in the code over there. So it's doing a bunch of pre-flights validation, hitting those vSphere endpoints, seeing if you have enough permissions, see if that folder structure exists, do you see if that particular template for creating those nodes exist, and whatnot. And then in the end, yeah, it's creating a bootstrap cluster. It's creating all those control plane endpoints, those etcd nodes, as well as the worker nodes, and applying all those configurations as CRDs so that it can exist on the cluster itself. Yeah. And then at the last stage, we also delete the bootstrap cluster at the end.
And so walk through that as well. I know we have it in the documentation too. Bootstrap cluster comes up locally, creates my workload cluster, and then transitions all my controllers over to the workload cluster and says, okay, now you manage this. Here's all my CRDs. Here's all my configuration that I used. And then the cluster that's running locally on my laptop goes away, and everything at that point is self-managed in the cluster itself.
That's right. Yeah, all the CRDs get moved from the Bootstrap cluster into the workload cluster, and you can manage your cluster using those CRDs and the controller running in your workload cluster from there on.
And I can manage that a couple of different ways, right? If I have the EKS control anywhere plugin or command line locally, I can still run commands against it. But also, I saw that you had the GitOps controller built into this cluster. So I'm assuming you want to show that off too, and just saying, hey, how do we actually modify and manage the cluster directly through a Git repo?
Yeah, that's coming a little later in the presentation, Justin.
So yeah, I might be jumping ahead.
Yeah.
So you're totally right. So you can use the CLI, which would again generate the Bootstrap cluster, and then get all those CRDs, and then do the update or how you want to manage it, and then push those updated configurations back into the workload cluster. Or you could use the GitOps way as well, where you just look at the configuration file, make those edits over there, push those checked in code, and then the controller would react to those changes in your GitHub repository, and then apply those configuration on the workload cluster itself, all without the CLI.
Right, so you don't need the CLI at all. That controller pulls that down. That's sweet.
Yeah.
Cool. I must say, I love Justin's excitement here. So he's been very closely working with our EKS Anywhere team, and he knows all the ins and outs. And in fact, he wrote our launch blog and a bunch of other documentation as well. So super excited. So this slide over here is a visual description of the cluster creation workflow that Vignesh and Justin just talked about. So effectively, you create the cluster spec file, and by the way, the file that Vignesh went over, you don't have to create that from scratch. So there's a command in EKS Anywhere on EKS Anywhere that you can use to create a template, and then you can just edit some of the fields. So to create a cluster, you create that cluster specification file, and it includes all of your vSphere details as well as information about your EKS Anywhere cluster. And then you kick off that EKS Anywhere create cluster command. And the reason Vignesh didn't go through it is because it takes about like 5 to 10 minutes, and we're just waiting around for the cluster creation command to complete. But effectively, what it does is it creates this temporary bootstrap cluster that you see on the left-hand side of your screen. And that's on the admin machine. And that's used to create the workload cluster in vSphere. And once that workload cluster is created, the cluster management resources are moved to your workload cluster, and the local bootstrap cluster gets deleted. And once your workload cluster is created, a kubeconfig file is stored on your admin machine with the RBAC admin permissions for the workload cluster. And essentially, you use that with kubectl to set up and deploy workloads. So there's documentation on all of this. We have pointers towards the end as to where you can find all of the documentation. But this is more like a visual interpretation. So just spending some time on just unpacking EKS Anywhere itself. So EKS Anywhere is a set of operational tools that we provide to customers to deploy EKS Distro-based Kubernetes clusters in their own data center and hardware. So it's opinionated cluster creation and lifecycle management tooling that you get. And what that means is that there's nothing proprietary. It's all open source. So we use upstream Kubernetes bits, and all of the integrated and bundled software is all open source as well. But we are going to be opinionated in terms of what we provide and how you can configure those clusters. For example, with the operating system, Vignesh was talking about it. We have a couple options. The default is Bottle Rocket, and you can also use Ubuntu. For pod network policy and CNI, customers can use Cilium. Cilium is a scalable Kubernetes CNI. It's open source, and it allows you to transparently secure network connectivity between application services that are deployed using Linux container management platforms. There's also OIDC support. So with EKS Anywhere, you can create clusters that support API server OIDC authentication. And that means you can federate authentication through Active Directory locally or through Azure Active Directory. You can also leverage the IAM role for service accounts, or URSA. And that feature allows you to enable AWS authentication. We're also looking to integrate with other identity providers. So let us know. So through the open source project, I'll give you a pointer to where you can open issues and let us know. There's also GitOps tooling. We have a Flux controller that allows you to create and manage configurations by pushing a YAML file to a repo. And the unstacked etcd, I think Vignesh briefly touched upon that. So essentially what you get with this is that it's an external etcd topology, which decouples your control plane components and the etcd member. So let's say your control plane node fails for whatever reason. It could be a memory leak in a component like the Kube API server. It doesn't impact your etcd member. And that basically helps you restore the state of your cluster back quickly.
And this is also good for performance, right? I mean, if we're running what we're calling stacked etcd in this case, if it runs on the control plane, I have my Kubernetes API server, I have any parts that are critical for running the cluster and etcd on the same nodes. And if something starts hammering the API, etcd could run out of resources at that point, right? So this
exactly.
Good practice. I mean, if I was running an application anywhere, I wouldn't necessarily put the database on the web server, right? Like that's just not really standard practice for any sort of three-tiered app. And separating out etcd into its own unstacked configuration with 3 separate VMs allows you to have full isolation, and etcd can consume all of the resources it needs on those machines for its own just database storing. And the API server and anything else in the control plane is only focused for all of its resources, serving, making sure the API is available and controllers there.
Exactly, yeah. And the last point was about connectivity to the EKS console. So we have a session on EKS Connector that's coming up where you'll have more details about how you can use that.
Next,
So quick word on EKS Distro. So EKS Distro is what provides the version consistency across Amazon EKS on the cloud and with EKS Anywhere on-prem. So we open source the Kubernetes version that Amazon uses for running Amazon EKS in the cloud. So you get the same major, minor, and patch versions. And this is basically the distribution that powers EKS. And you get all of the security and operational reliability that you get with Amazon EKS on the cloud. And AWS does the same testing, certification, and building for getting these Kubernetes versions released. So I think now we get into the second piece of the demo that Justin was referring to. So what we'll do now is talk about a cluster upgrade using a CLI, as well as show you some GitOps practices using EKS Anywhere. So over to you, Vignesh.
Thanks, Vipin. So so what I'm gonna do is I'm gonna kick off the cluster upgrade process using the CLI. So down below in the window over here, I'm going to edit the YAML file that we saw before, where I'm going to go and bump up the Kubernetes version from 120 to 121. And then I'm going to run through the EKS-kettle upgrade cluster command, supplying in this edited YAML file, as well as the kubeconfig to this particular cluster that we created in the step previous. So while that's running, just to explain what's going on in these windows over here, the above window is basically running a get pods on watch. And over here, we're running kubectl get KCP. KCP is actually short for kubeadm control plane. So KCP is one of the CRDs that we talked about a little earlier, which gets pushed and applied on the cluster itself so that the cluster could manage it on its own. Just below it, we have a get vSphere machines. vSphere machines, once again, a CRD definition for the custom resource. You could see that it's basically pointing to the 3 unstacked etcd nodes, as well as the 2 control plane nodes, as well as the 2 worker nodes. And then we are running a normal kubectl get nodes over here, which is describing the true control plane and the true worker nodes, and it also has the version pointing to 127 over there. So over on the left, there's like a sample application that's running on the worker nodes. In the logs that it's crawling over, you could see that it's basically doing those pre-flights validations that we were talking about a little earlier. It's going to stand up a bootstrap cluster. It's going to find the difference between the configuration that's on the cluster versus the one that was supplied in, and it's going to figure out that, hey, we want to upgrade this cluster version from 120 to 121. So at which point it's going to start the upgrade process. So over here, it's discovering that this is an existing cluster. So I'm going to get rid of the existing CRD so that they don't cause any confusion between the upgrade process. So it's getting rid of the CRDs, the vSphere machine CRDs, as well as the KCT CRDs, and then it's going to start the upgrade process where it's going to spin new nodes with the 121 version and start draining the old nodes with 120, which we will just speed through it and see it in a bit. So there was a 121 node that's already spun up, which is not ready. You can see the containers are getting spun up, like the Xilium, CNI, the kube proxy, the CSI nodes getting spun up over there. The nodes, the old node that's running 120 went to scheduling disabled, and it's going to get removed in a second over there. So this process is going to get repeated, for the worker nodes first, and then move on to the control plane. So at this point, you can see both the worker nodes are already upgraded to 121 version. So the next one would be to upgrade the control plane. Oh, there you go. So the control plane is to 121. It goes to not ready, and then when it becomes ready, it puts the old nodes to scheduling disabled and then drains it, and then gets rid of the node. So once this all this is done, you would see that the new cluster API CRDs, like the vSphere machines, the KCP, would be moved back from the bootstrap cluster that we created on our local machine into the cluster itself. So you see that the CRDs are getting created again with the updated configuration, so that the controller can start reconciling and match between the expected configuration and the state of the cluster itself. So this is the CLI upgrade process.
So yeah. I just want to walk through it again because I like the visual here of my running cluster had CRDs there that the CLI looked at and said, okay, I'm going to pull those into this local cluster I'm running so I can modify them, I can see what's going on. And then it actually, just like any sort of a deployment in Kubernetes, it does a rolling upgrade of my worker nodes, my control plane nodes, and then it pushes those CRDs back to be, again, just like it was before, self-managed cluster, controllers, everything in the workload cluster to be able to spin down the cluster on my laptop that was doing that work.
Yeah. So a quick note over there is it pauses the reconciling of the controllers over there on the workload cluster, and then gets rid of all those CRDs over there on the workload cluster, and then does the upgrade process, and then moves all of our CRDs back into the workload cluster, and then resumes those reconciliation process.
Right. I guess if you don't pause the controllers, you could end up in a really bad state when all your CRDs disappear.
Yeah.
Two quick questions here I can just bring up. Someone did ask about load balancer with EKS Anywhere, and to point out for anyone, like this is on-prem, completely managed in your environment. And so if you have an existing load balancer, it's Kubernetes. And so any sort of integrations that will work with Kubernetes, or if you have a F5 or there's plenty of hardware manufacturers that sell load balancers. If you're running one on-prem, there you go. In our docs, and thank you, Waleed, for sharing, we do have documentation on integrating kubevip if you want to run a load balancer, like a floating IP address within the cluster to be able to expose services. So I wanted to bring that up real quick because that is a question we often get. On-prem environments, not everyone always has a load balancer, and that's fine. At this point, EKS Anywhere is just giving you Kubernetes. Any existing ecosystem integration will still work with it if you have something, and then we just have some recommendation in our docs if you don't have anything.
Yeah. So the second part of the demo is where we try and scale up using the Flux, using GitOps. So over here, this is a live running cluster that we just upgraded in the previous demo. So just like the previous one, we are running a watch command on the get pods. The top right is actually showing the logs of the EKS-A controller. That's going to help us, look at the GitHub differences and then apply the new configuration. Over here, we are running kubectl get machines, and then down below it's kubectl get nodes. So what we're going to do is down in the bottom left over here. So we have this GitOps repo that our EKS-A create cluster command generated for us. So if you open up the YAML file over here, you would see that it's basically the one that we gave in as an input. So what we want to do is go in and update the worker node count from 2 to 3. It's still in 120, so we might have to pull down the new configuration because we upgraded through our CLI. So let's pull that, and then you would see that 121 is already here. And we are just going and I'm going to scale up the worker nodes over here. And let's create a commit out of it. Increasing worker nodes. So let's push it. I'm not following best practices for Git over here, but just for demo purposes.
Vipin should review it. It's okay. We'll get through the actual full pull request.
Yeah. Yeah, so once it gets pushed, you would see in a second over here on the top right column, you see a bunch of logs scrolling down. You'd see that there's a new configuration that it should take a look into and try to apply that configuration and try to reconcile the current status of the cluster to match the one that just got applied. We're waiting for a few seconds over there for that to get applied.
And again, just to say what's going on, you push this to GitHub. The GitHub repo is updated with that. You automatically merge it to master or whatever review process people have to get that merged.
Yeah.
The Flux controller, it's already deployed in cluster. There it goes. It says, hey, I'm just going to pull GitHub, see whenever this update comes in. As soon as I see something into master, the Flux controller is assuming Vipin reviewed it and did it correctly. I know I've approved some bad PRs. So this is you still have to have your own safeguards for how this is getting merged in. But the Flux controller says, okay, I see this main branch got changed. That is what I should merge the state of the world to. And it sees that you increase that worker node count. So the controller is then gonna update the CRD. Controller says, hey, 4 nodes or 2 nodes doesn't match 4 nodes, so I need to increase my node count.
Yeah, that's exactly what's happening. So you would see over here, the machine object just got updated to provisioning. It created a new machine object, which is in provisioning state. So it's going to wait for the controllers to go and spin up the actual node itself. Which actually just got spun up. It's not ready. Over here, pods are getting installed, like the CNI, the CSIs, the kube proxies. And then, yeah, there you go. There's a new node, which was brand new in 23 seconds, also running 121 cluster version.
In that case, this controller's, again, talking directly to vSphere APIs. And as Vipin mentioned earlier, we'll have more providers in the future. So if we want to do this on bare metal, if you want to do this with another provider, we have other options coming in the future, which will let you add nodes. I mean, in some cases, if this is bare metal, the controller doesn't open a PO to like order new hardware, but there'll be situations where you'll be able to add in Bootstrap and create a new node on bare metal or another option, not just vSphere.
Yeah, totally right.
Perfect. Yeah, so that's hopefully there's a good demo with cluster upgrade as well as like using GitOps to scale up your worker nodes. So just a note on GitOps. So essentially, we are using Flux, which is a tool that automatically ensures that the state of your cluster matches the config that is in Git. This is what Vignesh did when he put in the commit. The operator in the cluster actually triggered the deployment inside Kubernetes, which means that you don't need a separate CD tool. And it's the operator that makes GitOps happen in your cluster. And it ensures that your cluster config always matches whatever is there in Git. And the couple advantages and best practices with GitOps are that number one is you declaratively describe the entire state of your system in Git. So that means it includes all of the things like your apps, your config, dashboards, monitoring, everything. And the second thing is you really only push code, and everything is controlled through pull requests. So there's really no learning curve that's required for new developers on your team, and you just use the standard Git pull request process. So here's how we are thinking about GitOps to make your Kubernetes operations easy across on-prem and the cloud. And I believe Bob touched upon this earlier as well. So GitOps is going to be, it is an important aspect of EKS Anywhere, and we are starting to lean into that from an Amazon EKS perspective as well. And the whole intention is that customers will use their pipeline as a way to determine how the deployments will take place, rather than pushing everything to a central control plane. So basically, they push a YAML file and the config to a Git repo, and then the controllers that are running on both your EKS as well as EKS Anywhere clusters will change the clusters according to the changes that you make to your cluster spec. So a note on support. So we talked about the capabilities that we offer. So EKS Anywhere is open source, so it's going to remain open source, and we'll maintain the project. You can download it and use it for free. But if you let's say you want support for your production cluster, for example, so you can always reach out to AWS and get support. So AWS support for EKS Anywhere will broadly span two areas. One is the cluster control plane itself. So let's say in case you run into an issue with cluster creation, deletion, or configuration, for example, you can open a support case with AWS, and you can get support. The other is the third-party bundled tooling, things like Bottle Rocket or Ubuntu, Cilium, or Flux. You can, if you require any support for those bundled components, you can open a support case with AWS and get help. So that said, support is also going to be a shared responsibility model. And what I mean by that is, for example, the cluster upgrade operations will be owned by the customer. So we will provide the patches and the CVE fixes, but the actual operationalizing aspect is owned by the customer. Same thing with the application and code, as well as the physical server, storage, and network on premises. Any third-party tooling that you use, other than those bundled with EKS Anywhere, will also be owned by the customer. And for support for EKS Anywhere, the prerequisite is that customers already have an enterprise support plan with AWS, and customers can purchase a EKS Anywhere support subscription. Pricing is on a per cluster basis, so it's a flat fee, and there are two options right now. So either you can purchase an annual subscription per cluster for 1 year at $24,000, or let's say you would like a longer term commitment. So if you do a 3-year commitment, you get a discount, and support fee is $18,000 per cluster per year. We talked about the components throughout this talk today, but just want to quickly summarize. You get some operating systems that we're bundling. We're looking to add more options to that. So let us know if you have any specific requirements. Cluster lifecycle management, as well as scaling data and data plane upgrades. You get it through Flux right now. For CNI, we have Cilium, and then for GitOps, there's a Flux v2 controller. We have a session on EKS connector coming up next. For storage, we are not really bundling a storage solution, but any compatible CSI, any compatible storage solution, either on-prem or cloud-based, as long as it has the compatible CSI driver, you should be fine with that. We also require VMware right now for your on-prem EKS Anywhere clusters, but we're soon going to add support for other deployment targets as well. Just want to make a quick special note of all of our partners that joined us for the EKS Anywhere launch. We had about 35 partners, and we're continuing to add to that list. And the AWS partner ecosystem for containers is a rich and broad ecosystem and can help augment your EKS Anywhere workloads. So we have partners who are providing capabilities across foundation, DevOps, monitoring and logging, security, networking, and even consulting services. So we have a bunch of our consulting partners who are part of our launch. So we are super excited, and we are continuing to add to this list. Some resources for you. So So there's a link to the EKS Anywhere docs. I'm sure we'll share some of these with you after the session today. There's also the GitHub link where you can go and download EKS Anywhere and start using it. There's an FAQ page. So if you have any requests, like feel free to open a GitHub issue. Let's say you want like more bundled components, or you want support for something else. Like open a GitHub issue. Our team is looking at that. I'm looking at that as well. So we'll definitely be love to engage with you on GitHub. And we have a Slack channel on the Kubernetes Slack workspace. So feel free to take a quick screenshot of this slide, and we'd love to engage with you either on Slack or on GitHub. So I think we are almost there. And just to summarize today's talk, key takeaways are, we are super excited to let you know that EKS Anywhere is now GA. It's been GA for about a month now, and you get simplified installation and on-prem Kubernetes cluster operations. You can set up a highly available Kubernetes cluster control plane on-prem. And deployment is through Cluster API. It's open source. It's a Kubernetes open source standard. We also have integration with EKS Scuttle, which is consistent with whatever you're using today on EKS on the cloud. You get a bundled components as well as support for the control plane components and the bundled components from AWS. Reach out to us. And it's basically consistent control across on-prem and the cloud. So with that, I just want to say thank you for attending today's session, and hope you enjoy the rest of your day. We have some exciting content coming up. And I'll hand it over to Justin. If there's any questions that we can answer.
And Vipin, don't leave yet. A couple things. Open source. I just wanted to reiterate that, where this isn't just EKS Anywhere is open source, right? Like that's the piece that integrates Cluster API. It integrates like the spec and everything. But below that, like you said, Bottle Rocket's open source. EKS Control is open source. Flux from Weaveworks is open source. Like the entire thing, is from the OS level all the way up to where we're integrating it, all the controllers that we're deploying, all open source. So it's not even just this tool is in there. It's like, no, the entire stack is. In your slide earlier about if you want EKS Distro, which is just the binaries of Kubernetes that runs, you can run that yourself. We deploy those automatically, bundle them. If people need to modify their OVAs for something inside of vSphere, they can do that by building their own OVAs. And another thing that we didn't point out yet is there is the developer cluster locally, where you can actually just run in Docker. You can run all of EKS Anywhere locally in Docker. You don't need vSphere to try it out. So that's, if you have Docker installed on your laptop or a VM, go ahead and try that out. Like you can run it. It's not even something that you need any other sign up or access or accounts for. Pull down the bits and give it a try.
Absolutely.
And a couple things that I did see in comments as well. One, I saw a comment earlier about Raspberry Pi support and ARM support. I know it's not there yet, and Raspberry Pi support would require bare metal support.
Yeah.
But we get questions about Raspberry Pis and more of the hobbyist sort of like how to run this at home clusters. And so I know we are working on enabling, especially with bare metal, how we can get that available to people in the future so that they can try it out with less, less demand for resources necessarily in an entire environment that's like production ready. The other things that I wanted to pull in was monitoring. And because this is a shared security model, so how is monitor being addressed, and can it integrate with Container Insights? Container Insights is hosted inside of AWS. In this case, EKS Anywhere is a Kubernetes cluster that's running completely on your hardware in your environment.
Yeah.
So any monitoring agents will work, right?
Customers don't even need an AWS account. So you could run it without an AWS account. So in which case, you may not have Container Insights. So that's why it's meant for like on-prem use cases, disconnected use cases.
Right. So if you have on-prem Elastic, or you're shipping logs to Datadog or something like that, all of those integrations, because it is vanilla, it's just Kubernetes, those integrations will still work, but it is all running in your data center. So if you need like a direct connect or something else, depending on your network situation, that needs to be set up from your on-prem. And the last one I wanted to bring up, which Vignesh, you might be able to answer here, is can we do upgrades through GitOps if I wanted to actually do the 120 to 121? Is that available now? Is that coming? What's that story?
So so today we can't do that yet, but it's in the works. It's coming. Yeah.
Cool. Just wanted to make sure, like right now, the GitOps workflow has some limitations on what you can modify in cluster, and the CLI has other things that you can do with the Bootstrap cluster. So just wanted to set that as a level, like everyone understands. We're working on enabling as much as possible in GitOps workflow with Flux, and those will be coming soon.